Welcome back to Forbidden Knowledge News. I'm your host, Chris Matthew. Tonight, my guest is Randall Carlson. Before I bring him on, I need to tell you about My Patriot Supply, especially right now. They're the experts in emergency preparedness. Right now, we're at a super critical time in our history. We have a very unsure future, especially when it comes to our food supply. So it really couldn't hurt to have an emergency food supply. I have one. I feel so much better. Right now, you can get $70 off a 2-week supply and $100 off a 4-week supply of their amazing food. It stays good in storage for up to 25 years. Just visit preparewithfkn.com or click the link in the description to get your food supply today. Please remember to subscribe to Forbidden Knowledge News on lbry.tv. It's our official backup channel. And check out our brand new show, Beyond Classified, exclusively on Rokfin. It's also available on the Forbidden Knowledge News podcast. Finally, check out Forbidden Knowledge NewsCon 2021. Go to our website at forbiddenknowledge.news to check out this year's awesome lineup and get your tickets. It's going to be April 2nd, 3rd, and 4th. We're going to have 12 amazing presenters. You really don't want to miss this year's lineup. Like I said, that's at forbiddenknowledge.news or click the link in the description. Check out the lineup. Check out what the topics are going to be. We're going to have some awesome roundtable discussions and 12 awesome presenters. All those links are in the description. Be sure and check that out. Tonight, I want to welcome back to the show Randall Carlson. He is a master builder and architectural designer, teacher, geometrician, geomythologist, geological explorer, and independent scholar. He has nearly 5 decades of study, research, and exploration into the interface between ancient mysteries and modern science. He has been active Freemason for 43 years and is a past master of one of the oldest and largest Masonic lodges in Georgia. His work incorporates ancient mythology, astronomy, earth science, paleontology, symbolism, sacred geometry, and architecture, geomancy, and other arcane science traditions. For over 30 years, he has presented classes, lectures, and multimedia programs, synthesizing this information for students of the mysteries. It is his aspiration to effect a revival of lost knowledge towards the goal of creating the new world based upon universal principles of harmony, freedom, and spiritual evolution. Randall, welcome back. How are you doing tonight?
I'm doing great, Chris. Thanks for having me back.
Yeah, I was looking forward to this. Last month when you were on, we were discussing some past cataclysms, mainly asteroids, possibilities of future cataclysms. We barely scratched the surface on some of this. Tonight I want to go a little bit further. I want to talk some mega volcanoes, possibly earthquakes that we've not really heard much about. You know, we mainly hear about the asteroid impacts when it comes to these major cataclysms, you know, especially with mainstream academia. And I'd love to hear about some of the mega volcanoes that could have had major impacts on our planet throughout history, mega earthquakes. And then if we have time, we'll discuss the possible ancient technology that could have been used for some of these megalithic structures and buildings, and the knowledge that they may have lost during some of these cataclysms that we're going to be discussing tonight. So I thought, let's start with some mega volcanoes. We have evidence of the mega volcanoes in the United States as well that have had major impacts on our planets. So what are some of the most profound ones that we should start with tonight?
I would say start with Tambora. This was the great eruption of 1815 that triggered what has been referred to as the last great subsistence crisis of Western civilization. And the aftermath of that particular eruption has been known as the year without a summer. I'm not sure if you're familiar with that or not, if you've ever heard of that event.
I have, yes.
Yeah. So this was from a study in 1992, the eruption of Tambora in 1815, the environmental effects and eruption dynamics, published in a colloquium entitled "The Year Without a Summer: World Climate in 1816." After 4 days of minor activity, the volcano became very active on April 10th. Witnessing the activity from Sangar on the eastern slopes of Tambora, the Raja described it the second and larger major eruption. At about 7 p.m., 3 columns of fire rose high from Tambora's crater, uniting in a single firestorm over the volcano. Moments later, the entire mountain was a sea of glowing flows which spread in all directions.
And where exactly was this located again?
I am going to pull up a map in 1 second, Chris.
Oh, yeah.
And,
Go ahead.
And you'll see. I'll show you where it was. Between 9 and 10 p.m., the ashfall increased and a strong whirlwind descended, carrying off houses in Sangar and nearby villages. In the part of Sangar nearest to Tambora, the largest trees were uprooted by the windstorm and carried off with houses, people, and livestock. These descriptions are consistent with the passage of a pyroclastic surge through the village. Sea level rose suddenly by 12 feet. Okay, so now let us go to a screen share and we'll look at a map and see where this occurred. Okay, so you see this string of islands here. Let's see if we can't open this up like this. There we go. Here's Tambora. You see it right down here where my cursor is, and we'll look at a larger map in a second so that you can see where this is. Here at this place, notice Makassar, whatever, however you pronounce it up here. Here's the volcano. So at noon on April 12th, the darkness is so total that a hand in front of one's face cannot be seen. There is the aerial view of the caldera as seen today. 7 kilometers wide, that's about 4.5 miles, and 1,100 to 1,200 meters deep. So 3,600, that's close to 4,000 feet at 1,200 meters, and has an ephemeral freshwater lake. Ephemeral means that it comes and goes depending on the amount of precipitation. A small active vent called Doro Afaitoi has formed at its base. And that is right down here in the lower right-hand corner. The seismic and tectonic activity of the volcano is monitored by the Indonesian Center of Volcanology and Geological Hazard Mitigation. So it's in the Indonesia archipelago. Here's another of Tambora in Indonesia, the most powerful volcanic blast in recorded history. So let's see here. So now this is interesting because here you'll see the forest and the regeneration of the forests creeping up compared back to, let's see, yeah, there you can see the forests. And of course, in 1815, the entire surrounding was basically this lunar landscape you see here. So the regeneration of the local ecology, to me, is a very interesting phenomena. So I'll stop to share for now, and we'll go on. We'll be looking at some of these, some of the comments and writings about the event of Tambora eruption. So here were some of the immediate effects. The consequences of the Great Tambora eruption were not confined to the region of the Indonesian archipelago, but were felt worldwide. And you know what? It's probably a good idea for me to, I've got Google Maps here, to give you the bigger view so you can see where on the planet we're actually talking about. So I'm just going to take a second here to get this open because we may be wanting to refer to this.
Yeah, that's great.
Multiple times here. I am a cardophile. I love maps.
Yeah, it's great for the audience to have to get a perspective, on where everything's located as we're discussing this. So
Yeah, so
that's
here
a
we
great
go.
idea.
I'm getting it here. I'm going to go ahead and put on the terrain modeling. Uh, let's see here. There we go. Okay, great. I got it. So let me uh, go back and do another share screen.
And for those of you that are listening on the podcast, to check out the video version and see what Randall is sharing here, just go to YouTube and you can see all the presentation there.
Cool. Yeah. Okay, so I'm going to zoom out. All right, so we can kind of see the orientation here. Here's Australia. Here's in the Indochina area, China. So we're going in here. We're going to zoom in. You'll notice Vietnam, Cambodia, Thailand up here, then Malaysia. And down here, here's that string of islands we were just looking at. All of this is Indonesia, right? So here's that Makassar, or Makassar is probably what it is. And we'll keep zooming in, and it should be coming visible right about now. Right there, Mount Tambora. Let's go ahead and zoom on in a little closer. There it is. So I'll back out again so we can see now. Remember, we pointed out that as far away as this right here, this island, the South Sulawesi, the South Sulawesi Island, which is part of Indonesia, the Indonesian archipelago. At noon, it was so dark you couldn't see your hand in front of your face. So that's a lot of stuff in the atmosphere. Okay, so I'm going to stop share now that everybody has seen that. We're going to go back to discussing the effects. So the effects were felt worldwide, sometimes to a considerable degree, even years later. In 1815, there were no means by which one could know of such an event in real time if one was beyond the region of immediate destruction, right? Big difference between 1815 and now. But the effects were certainly experienced far removed from the scene of catastrophe, without those affected knowing either the source or cause of the forces of nature upsetting the balance of their world. The Great Tambora eruption triggered a series of events that historian John D. Post has called the last great subsistence crisis of the Western world. Along with the ash, pumice, magma, and pyroclastic flows, pyro means fire, right? And clastic are pieces of material. And because you have a lot of material, these are the clasts. You have clastic material, and it's being swept along in this current or flow of magma, of literally melted rock. And that is a pyroclastic flow. So you had ash, you had pumice, which can form large boulders, literally, that fall from the sky, magma, and pyroclastic flows. Mount Tambora ejected large quantities of sulfur dioxide into the atmosphere. Now, sulfur dioxide is not stuff you want to have loaded into the atmosphere. Estimates have varied as to the exact amount, but have ranged from 10 million up to more than 100 million tons. Evidence would suggest that the quantity was toward the higher end of the range. When silicon dioxide is injected into the atmosphere, it reacts with water to form sulfate aerosols, which in turn produce acid rain and deplete the ozone layer. A large energetic volcanic eruption like Tambora will inject the sulfur dioxide up into the stratosphere, where it forms a volcanic smog that is beyond the dispersal capability of wind and rain. Here, the stratospheric sulfate aerosol veil, as it has been called, reflects sunlight back into space. The consequences of that should be obvious. The Earth undergoes cooling until the aerosols eventually disperse. So, in the Pittsburgh Daily Post that came out in January 3rd, 1916, which was the centennial of the year without the summer, they did a story on that particular event that had happened 100 years earlier. And it's pretty explanatory and descriptive. So I'll read it here. This is from the Pittsburgh Daily Post, January 3rd, 1916, an article entitled A Year Without a Summer. When old probabilities upset things to such an extent as to make us wonder as to the existing unusual period of weather, it is possible to reconcile the condition by going back just 100 years to 1816, when we had a year without a summer. This was one of the most unusual years as to weather conditions that has ever been recorded. From fragments collected from newspapers of that period, it is evident that in 1816, the average temperature during the summer months was so low that many persons were led to speculate on the possibility that the seasons had changed. There is evidence to be found that in 1816, there were sharp frosts in every month. April opened mild but grew colder as it advanced, ending with snow, ice, and winter cold. In May, ice formed a half-inch thick. Buds and flowers were frozen and corn killed. Frost, ice, and snow were common in June. Now this is in Pennsylvania, right? Because this is the Pittsburgh Daily Post. Almost every green thing was killed, and the fruit was nearly all destroyed. Snow fell to a depth of 3 inches in New York and Massachusetts and 19 inches in Maine. July was associated with frost and ice. Corn was almost all killed in the northern states. In August, ice formed a half-inch thick. A cold northwest wind prevailed almost all summer. So, yeah, that was pretty traumatic for the people who were living through that. And this is why it was referred to as a subsistence crisis. A letter from Erie, Pennsylvania. Here's they quoted a letter from Erie, Pennsylvania, dated June 14th, again 1816. This is what the letter says. The season has been dry and frosty for weeks together. It appears as if we should have no crops in these parts. The corn has been killed by the frost, and until very lately, Lake Erie was not navigable because of the ice. During 1816, spots were noticed on the sun, and some persons attributed the unusual weather to these spots, while others thought that the earthquakes that were felt in South America and Lisbon had something to do with the unusual conditions. At any rate, the change was so great from preceding summers that the people made up their minds that some mysterious force was at work making over the world.
Wow, that is fascinating. Now, this only lasted for one summer, and it dissipated, and things eventually
the effects lingered for 3 or 4 years.
Oh,
but
okay.
that first summer was by far the worst, because by the next summer, a lot of the aerosols and the dust and everything had begun to be cleared out. But one of the correlations that I thought was really interesting was the observations of a lot of sunspots and the occurrence of multiple earthquakes in several other places around the world. And this leads us to a really interesting possibility to which I don't have any definitive conclusions as of yet. But there does seem to be enough circumstantial evidence to suggest that there is these periods of intensified activity that includes things happening with the sun, that includes volcanic, and it includes seismic. Interestingly, it also seems to include, in many cases, extraterrestrial activity in the form of meteorites, more enhanced fireballs, those kinds of things. And so I think possibly what we're approaching here, Chris, is a new model of understanding how our planet works, how this world works, that it's part of a much larger cosmically integrated system that, for example, and we can get to this in our discussion tonight. For example, what happens, the new family of comets that are called Kreutz sun grazers. And it seems like there are periods of enhanced cometary influx to the sun on a much more prolific scale than anybody was imagining a few decades ago before we had solar observing satellites in place. But it seems like there's a correlation between the intensification of the flux of the sun grazing comets, the response of the sun, and then in turn, a terrestrial response. Because if the heliosphere is undergoing some kind of oscillation of some kind, and then we have our Earth, which is immersed in that heliosphere, and its geomagnetic field and the heliosphere are like this. So clearly, if something is causing perturbations in the heliosphere, it doesn't seem too much out of the question that it could also be causing perturbations in Earth's geomagnetic field. Now, if that's happening, it may be linking seismic activity. It may be linking volcanic activity. So, and then of course weather as well. All of these things might be all linked really in this kind of cosmic dance. And I think what we're seeing is that the evidence is really pointing in that direction. And so we need to really be thinking on this sort of, what can I call it, a cosmically holistic scale to understand what's going on right here down below in this planet that we live on.
Now, would you think that it's the area of space that our solar system is passing through, or is it the sun, the cycle that the sun is going through, or maybe even a combination of both? What do you think?
Yeah, that's what I would lean towards, Chris. I think it's a combination of both. I think obviously that the sun itself is. See, here's the thing too. All right, in observations of solar-like stars that we've seen, what we've been observing now for a few decades, what it certainly seems like, and this is goes contrary to some of the modern assumptions about our own sun, but that is some of these stars that seem to be solar-like in a lot of respects also seem to be very, very variable, much more so than we've assumed our own sun to be. But one of the important things here, takeaways from that, is that maybe our sun is more variable, and a couple of centuries of observations are not going to be enough to draw long-term conclusions about solar variability. And we, in a few minutes, I can get into some of the sun grazing phenomena and the connection between that and solar storms, for example. So, yeah, that's the idea here. I think that we're coming into a kind of a new model of when we talk about the world, we're not only talking about just the planet, we're talking about like the whole solar system. And then you even said the solar system through the galaxy may be having effects on a galactic level. And there are a number of possibilities there. One being that because our solar system oscillates above and below the galactic plane, and because most of the material, especially the finer material of the galaxy, is concentrated towards the galactic plane. So if it takes roughly, say, 26 million years to make that oscillation, okay, so what that means is that if that's correct, and some of this work has been done by people like Michael Rampino and I think Struthers, Richard Struthers, others, I can pull some of that up if you need the exact references. But the idea being that if you're passing through this zone of concentrated material, it could be that our solar system accretes some of that material to it. It could be that some of that activity, that increased density of the galactic plane, could cause a destabilization in the reservoirs, the cometary reservoirs. The Kuiper disk, which is out beyond Neptune, and the Oort cloud, which wraps around in a giant spherical cloud of comets. So now it seems like, and this is way oversimplified, but what it seems like is that the progression, the evolution, is that you have the Oort cloud sphere that is probably being modulated by galactic effects, which could very well be the oscillation, the 26 million year oscillation of the Earth above and below the galactic plane. Okay, so it could be that. But whatever, it could be also being affected by supernovas, passing neutron stars, for example. There could be a number of forces on the cosmic or the stellar, the cosmic, the galactic scale that are causing enough perturbations to that Oort cloud that these comets, which are all, picture now, they're not just like this, they're orbiting slowly around the sun, right? Now, if they're dislodged from these orbits, and these are quasi-stable orbits, essentially, it doesn't take much to move them out of their orbit. But the thing is under normal circumstances, there isn't that much. But if there is a exception to that, like I said, that a supernova explosion or something occurring on the galactic level, okay, that causes those comets to become unstable, they begin to migrate in towards the sun, and they also have a tendency to move down towards the plane of the ecliptic, which is essentially the orbital plane of the planets extended out. Now, when it does that, it transfers and becomes part of the next reservoir, which is the Kuiper disk. Okay, so now if a comet is delivered directly into the inner solar system from the Oort cloud, it tends to be following a parabolic or even a hyperbolic orbit. What that means is its trajectory is open-ended. So if it comes in, and usually the sun's gravity field will pull it in, it'll make a loop around, and it's speeding up. Of course, the closer it gets to the sun, the faster it goes. It goes around the sun and starts back out. And because of the fact that the geometry of a hyperbola or a parabola is open-ended, the assumption is it's going, it's goodbye, it's never coming back. On the other hand, a comet that's captured into the ecliptic plane now can become bound between Jupiter and the sun, is typically what happens, right? The two greatest gravitational forces in the solar system, and the comets will get captured between them. Now, if it's a large comet that could be a nucleus of 50, maybe even 100 miles in diameter, and that comes into this part of this celestial ping pong game and starts fragmenting in a hierarchy of fragmentation events. That stuff now, its ultimate fate is going to be, it's either going to get most commonly swept up by the sun, swallowed by the sun. Secondly, it continues to disintegrate and becomes a layer of dust. Thirdly, the dust or more macro scale pieces can accrete to the planets. So on Earth, that would be, we would get an impact. And whether struck the ground, exploded in the atmosphere like Tunguska, all depends on a bunch of stuff. Mostly the velocity of approach and the density of the object will determine, along with the size, whether that object, comes in and hits the ground. Here we go. Let's see it. There we go. Hits the ground, leaving a crater, or it explodes up in the atmosphere. In which case it doesn't leave a crater, but it can cause a hell of a lot of surface damage. Now, if those objects are falling into the sun, it seems now that what has been observed, and we can pull that up and get into that, and we will, the connection between the infall of these sun grazing comets and solar activity.
Yeah, let's talk about that. The effects that those sun grazing comets might have as they impact the sun and then afterwards.
Yeah. All right. I mentioned Michael R. Rampino, and we'll come back to that. I'll just hit a couple of more points about the Tambora eruption.
Sure.
And so Rampino wrote back in 1992 in that same collection that I was quoting from before. He says, the reply gives evidence of a direct cooling associated with the ash cloud, and such a cooling effect was observed as far away as Madras, India, where midday temperatures fell below freezing as the cloud passed overhead. The anomalous weather of the infamous summer of 1816 was quite likely related to the radiative perturbation by stratospheric hydric sulfide, H2SO4 aerosols, generated by the eruption. Without doubt, a similar eruption in Indonesia today would be a regional disaster and would create a global atmospheric perturbation of a magnitude not seen in almost 2 centuries. And of course, this was written in 92, so now we could say it would create a global atmospheric perturbation of a magnitude not seen in over 2 centuries. In the spring and summer following the eruption of Tambora, the northeastern United States was subjected to a dry fog that so dimmed the atmosphere that people could look directly at the sun. And in some cases, they were actually able to observe the sunspots with the naked eye. The fog was strangely tenacious and was not dispersed by either surface wind or rain, which is consistent with the expected behavior of a sulfate aerosol veil. The consequences of the bitter cold that afflicted the Northern Hemisphere in the year 1816 were far reaching. The reverberations of that event are still echoing today. In the next part, I will describe what happened in the aftermath of the Great Tambora eruption and the central role it played in influencing the vector of modern history. So, what I just read from was actually a chapter of the book that I'm writing. As I go on to say, in part one, I introduced the reader to some of the details surrounding the eruption of the Indonesian volcano Tambora in April of 1815. I described the immediate consequences of the eruption upon the flora, the fauna, and the human population of the island. But the effects were not confined to the immediate region of the Indonesian archipelago. Instead, they rippled out from that epicenter of the disaster to encompass the globe. Gillen D'Arcy Wood Nicholson, professor of English and director of sustainability studies at the University of Illinois, has researched and written extensively on the Tambora eruption and its aftermath. He has written that to be alive, and I quote, to be alive in the years 1816 through 1818, almost anywhere in the world, meant to be hungry. He points out that the year without a summer was actually a 3-year climate crisis, during which harvests perished from a deadly triumvirate of frost, drought, and devastating floods, each the manifestation of the chaotic climatic effects induced by Tambora. So that kind of is really showing that, and again, we haven't had anything on that scale since then. But if we did, and we surely will again, hopefully we're going to be prepared for it. Because can you imagine just even 1 year with half the crops of northern hemisphere being lost to the cold and the frost?
Oh yeah,
That would
it
put
would
some
be
serious strains on our economies.
devastating.
And yeah, and most likely cause a lot of people to get hungry.
Yeah,
And you
that
know
would
what
definitely
happens?
be.
You know what happens when people get hungry and they haven't had proper nourishment?
Yeah, they get
Their
desperate,
immune systems get weak and compromised.
and
And you know what happens when people's immune systems get weak and compromised? They become vulnerable to opportunistic viruses and bacterias. And when you look in the last couple of thousand years of history and you look at the great pandemic events, they're always preceded typically by a global cooling event, such as we've just been talking about here. Now, a similar event can be brought on also by an impact, which can generate a huge amount of atmospheric pollution.
yeah, and yeah, I can only imagine. Nowadays in modern history, we haven't had any major cataclysms in anybody's modern lifetime. So, we wouldn't really know how the populace would react to something like that.
Right. And that's a very good point, Chris. In a way, I think we could almost even surmise that we've been able to accomplish what we have in the last couple of centuries because we've been spared those kinds of events. And, when we're looking at these events now and we try to understand global change, we have to be looking at all of these things. We have to be looking at volcanism. We have to be looking at um, changes in the Earth's geomagnetic field. We have to be looking at changes in the radiative output of the sun and the activity or inactivity of the sun. We have to be looking at things on the galactic level. We have to be looking at all these variables because they're all coming together to create not only the weather, but the climate, right? And carbon dioxide is certainly a factor, but it's not the only one, not by a long shot. And in fact, I think in the larger scheme of things, carbon dioxide relative to its role in climate change is going to be demonstrated to be relatively insignificant at the concentrations we're looking at now, because carbon dioxide is most effective in terms of trapping thermal energy in its lowest concentrations of 100 parts per million. And then as you increase each 100 part per million increment, what is happening is that thermal capture ability of carbon dioxide is falling off logarithmically. So each increment is like a tenth of the previous increment. And what that means is that most of the heat capturing of carbon dioxide is literally in the first 50 parts per million. 100 parts per million is as much as is actually more than it's 400 parts per million now. So there's more thermal capture in the first 100 parts per million than there is in the 300 parts per million between that level and where we're at now. So what happens is that the modelers, the computer modelers who make projections upon which we are supposed to base our economic response and our activity and everything, is based upon injecting feedback processes into the models to ramp up or to amplify the effects of carbon dioxide. Without those positive feedback amplifications, carbon dioxide doesn't turn out to be diddly squat. So you have to ramp it up. And the way it's ramped up is through a series, a crescendo of feedback processes, which works like this. Carbon dioxide increases. What that does is it slightly increases the warming of the earth, which causes a slight increase in water evaporation from the oceans, which then adds, because see, water vapor is far and away the most effective greenhouse gas, right? So you ramp up a little bit of water vapor, it captures a little more heat. Now that little bit of heat warms up the ocean a little bit more. Then the ocean outgasses more CO2. and it evaporates a little more. And now you get this, the idea is it's like ping pong back and forth. You see, each one ramps up a little bit more, and then we're ultimately driving it because we're pumping CO2 into the atmosphere. So the point being of all this is that to get the catastrophic projections of 2 to 4 degree warming, you have to amplify the initial minimal effect of carbon dioxide through the use of water vapor. The problem with that is increased water vapor in the atmosphere increases cloudiness. And cloudiness on the net reduces incoming solar radiation, which then is cooling rather than warming. To what extent has that been factored into the models? And the big variability in the models that even the modelers themselves will admit to is the unknown role of clouds and how clouds should actually be factored into the models to get a real world projection from it. But in broad terms, more water vapor translates to, yes, more thermal capture, but it also creates more clouds, and clouds tend to reflect more warmth than without the clouds. So all of this is having to do with the fact that there are also natural sources and sinks of carbon dioxide that need to be factored in. And, these natural events can do that. So the other part is the thing we were talking about is we could get into some of the sun grazing comet things. We can come back to volcanism clearly because there's a lot more here.
I'd love to get into the sun grazing comets and solar storms as well, and some of the effects that might have had in our past.
This is from Joanna D. Haig, who is a climatologist and solar physicist, written back in 2001. And it's from an article that appeared in the journal Science entitled Climate Variability and the Influence of the Sun. This is what she says. The search for the signs of solar variability in climate records has historically been dogged by overstated claims and dubious statistics. In addition, ground-based measurements were insufficiently sensitive to detect variations in the sun's radiative output. As a result, the subject has tended to be marginalized by the meteorological establishment. However, recent evidence from satellite data has shown that the term solar constant is a misnomer. Furthermore, climate change attribution requires the ability to separate natural climate forcing mechanisms from human-induced factors. It is thus more important than ever that the influence of solar variability on climate is assessed and understood. Now she's referring to one of the feature articles in that particular issue of Science written by Gerard Bond and colleagues, who were quite prominent scientists back in the latter part of the 20th century and going into the 21st. Who investigated things like ice ages and solar variability and so on. So in this particular issue, Bond and his colleagues investigate the influence of the sun on the climate of the North Atlantic region during the Holocene epoch from about 11,000 years ago to the present, using data extracted from deep sea sediment cores. The level of solar activity is estimated from the concentration of carbon-14 and beryllium-10 isotopes, which are produced by the action of galactic cosmic rays. Cosmic rays are more intense at Earth's surface when the sun is less active. So right there, you see, we've got that connection, the galactic connection again. Because the solar wind tends to act as a buffer, as does Earth's geomagnetic field. So the galactic cosmic rays coming in that bombard neutrons in the atmosphere, causing the formation of isotopes, primarily carbon-14 and beryllium-10. Carbon-14 is incorporated into the biosphere, into the plants. Beryllium-10 will precipitate out of the atmosphere in the form of rain and snowfall. So one place that the beryllium-10 concentrations can be found is in ice core layers. So in other words, you're going through an ice core layer and you look at a particular layer and there's let's say 10 times more background of beryllium-10 than normal. And then you look in the biological record and you look at plants that can date to the same period and you see there's a spike of carbon-14. So one of the things then that suggests is that one of three things had to have happened. There was a major intensification of galactic cosmic rays, or the sun's, the solar wind, part of the heliosphere, its insulating capacity of Earth's atmosphere was somehow compromised or mitigated, most likely through solar activity, or Earth's geomagnetic field underwent a diminishment in its power. See, so, or you've got these things all interacting, but the point is there are times when there's an enhanced bombardment of the Earth by galactic cosmic rays, and when that happens, it creates signatures, fingerprints that can be measured. So let us go on with some of this interesting stuff here. I should go back actually to one of the early researchers who was John Eddy, who did a lot of work back in the 60s and 70s. He published a paper in the Bulletin of the American Astronomical Society in 1975, in which he's the paper's entitled A New Look at Solar-Terrestrial Relations. And he starts out by referring actually to an earlier scientist who was studying the sun, wrote a book called The Sun and Its Influence, a simple text on solar-terrestrial relations. This book had chapters on solar flares, on their effects on magnetic storms, ionic disturbances, aurora, and cosmic rays. Now remember, aurora, like aurora borealis or northern lights, is formed by the cosmic rays bombarding the Earth's atmosphere. The space between the sun and Earth was assumed to be quiet, static equilibrium, broken now and then by the passage of solar storms. Nothing was said of the influence of sun on weather, for little was known with certainty. Then came the deluge. Since 1955, now remember, this is in 1975, this is being written, we have sent nearly 2,000 instrumented spacecraft into the void between the Earth and the Sun, including 12 years of OSOs and an intensive Earth solar program on Skylab. The number of workers in solar and solar terrestrial physics has increased dramatically. We found the Van Allen belts, a solar wind, evidence for ordered magnetic structure in interplanetary space, and a complex outer terrestrial field that bears little resemblance to the simple picture in Ellison's book. We have measured drastic changes in the solar output in the ultraviolet and X-ray regions, and have seen new species of dynamic solar events. Do we know any more about the practical influences of the sun on the Earth? How much closer are we to predicting terrestrial effects caused by the sun? What do we know of the most pressing solar-terrestrial relation, the influence of the sun on climate and weather? And see, that question that was asked in 1975 is still not answered sufficiently to come to any final conclusions about the matter. However, what we have learned since 1975 is certainly 100% supportive of the conclusion that there is a major effect of the sun on both the weather and the climate. And it's interesting that the Intergovernmental Panel on Climate Change has generally assumed no particular effect of the sun because of the idea of the solar constant. In other words, if the assumption is made that the radiative output of the sun is invariable, well, then there's no effect, right? So if you make that assumption, then it's then possible to ignore the role of the sun. And I would venture to suggest that, my friends, is a big mistake.
Now, as far as some of the major solar storms that could have had a huge impact on our planet and life on our planet, um, how far back would we have to go to look for a major solar storm?
Well, let's see. We could go back to the Harrington event. Let's see. We could do that. Yeah, and I can pull up something here on the Harrington event. So
Sure.
we'll come back to that. Okay, because we can we'll circle back to that.
Sure.
And this is from The Role of the Sun in Climate Change, written by Douglas Hoyt and Kenneth Shatton, 1997. So we've jumped forward by 22 years from that 1975 paper by John Eddy. But still, this is what they're saying in 1997. The sun's role in past climate change is not well understood. Some researchers believe the sun plays the major role in natural climate variations. Others say it's a negligible role. We favor the viewpoint that solar activity has been increasing in this century in a way that appears to fit the global temperature record, a fit that is perhaps better than the variations in carbon dioxide. The climate system is more complicated than a direct one-to-one relationship between carbon dioxide and temperature. Jump forward a couple of years from that, a paper that appeared in Quaternary Science Reviews, The Role of Solar Forcing Upon Climate Change. And here's what this team of highly distinguished scientists who've been studying the sun have to say. Evidence for millennial scale, now this is 1,000 scale, climate changes, and this is addressing your question, during the past 60,000 years has been found in Greenland ice cores and North Atlantic ocean cores. Until now, the cause of these climate changes remained a matter of debate. But here we argue that variations in solar activity may have played a significant role in forcing these climate changes. We reviewed the coincidence of variations in cosmogenic isotopes, carbon-14 and beryllium-10, with climate changes during the Holocene and the upper part of the last glacial, and present two possible mechanisms involving the role of solar ultraviolet variations and solar wind/cosmic rays that may explain how small variations in solar activity are amplified to cause significant climate changes. Accepting the idea of solar forcing of Holocene and glacial climatic shifts has major implications for our view of present and future climate. It implies, and here's the key takeaway, it implies that the climate system is far more sensitive to small variations in solar activity than generally believed. Comment there is that, yes, if it turns out, and I would say there's a very high probability of this, that the sun has been the major driver of climate change for at least the last couple of centuries, and the carbon dioxide increases have only played an incidental role. If we exclude our consideration of the sun and focus only upon carbon dioxide, if we experience a period of intensified solar variability, or let's say inactive sun, which is correlated now with periods of global cooling and the onset of ice ages, if we ignore that, well, we could be getting ourselves in a world of trouble, you see. And what we've gotten into is just here is really just the scratching the surface.
Yeah.
But let's see. Ernest J. OPEC. I'm going to jump back for a minute. Well, wait a second. Let me see. I'm going to come forward here. Let's see. Yes. Okay. So this is very interesting, what I'm about to share with you, and it's has tremendous implications, which have actually been, for the most part, ignored by the scientists who are being funded by the government to produce, I think, a predetermined outcome.
Right.
But consider this. Here's what it says. The solar wind is an extended ionized gas of very high electrical conductivity, and therefore drags some magnetic flux out of the sun to fill the heliosphere with a weak interplanetary magnetic field. Magnetic reconnection, the merging of oppositely directed magnetic fields between the interplanetary field and the Earth's magnetic field, allows energy from the solar wind to enter the near-Earth environment. You see, so you've got the interplanetary magnetic field, and you have the Earth's magnetic field, so they interconnect. That's the whole point here. Through that connection between those two magnetic fields is what allows energy from the solar wind to enter the near-Earth environment. The sun's properties, such as its luminosity, are related to its magnetic field, although the connections are still not well understood. However, changes in the heliospheric magnetic field, now the heliospheric magnetic field pretty much encompasses the whole solar system, okay? So just to get the scale and the picture of this thing. You know, think of the Earth being surrounded by this envelope of atmosphere, right? And how far the atmosphere extends out. Well, then the Earth's geomagnetic field extends beyond that. The sun itself, the heliosphere is this zone, roughly spherical, in which the influences of the sun predominate. So now we're getting to the crux of the matter here. Moreover, changes in the heliospheric magnetic field have been linked with changes in total cloud cover over the Earth, which may influence global climate. Here, we show that measurements of the near-Earth interplanetary magnetic field reveal that the total magnetic flux leaving the sun has risen by a factor of 1.4 since 1964. Surrogate measurements of the interplanetary magnetic field indicate that the increase since 1901 has been by a factor of 2.3. This increase may be related to chaotic changes in the dynamo that generates the solar magnetic field. We do not yet know quantitatively how such changes will influence the global environment. But this is very interesting because that enhancement, right, of the solar magnetic field seems to be roughly in the same proportions as the increase in Earth's temperature. Now, who's going to step forward and say there's no connection between the variability of Earth's climate and what's going on with the sun? No, the best thing to do is just keep quiet about it.
Right.
Not include it in your models, and the average lay person is not going to know any of these things that we're talking about right here and now.
Yeah, it's unfortunate. It's unfortunate that modern day science and academia has to take that approach because, they're worried about, staying in the game, keeping their tenure, whatever they have to do to not be, to stay in their state of play,
Yes.
It's very unfortunate. Now we have a little bit of time left. I knew we'd barely be able to get to scratch the surface of some of this stuff again because it's so much. There's so much that we can go into. But I do want to get into a little bit about sacred geometry and ancient builders of the past, especially the possibilities of construction of pre-flood construction and the technologies that could have been used. And I know sacred geometry was a big part of the construction that the ancient used. Now, for those that really aren't familiar with the principles of sacred geometry, could you kind of go over some of the basics and how the ancients came across, using this for their building techniques?
Well, the ultimate origin and how it became incorporated into the methodology of ancient builders, I can't really say. But the traditions are pretty clear on what its ultimate origin was. Galileo, I think, expressed it quite succinctly when he said this: mathematics is the alphabet with which God has created the universe. Now, which kind of echoes what St. Augustine said centuries before Galileo when he very succinctly said this: numbers are the thoughts of God. And Johannes Kepler said geometry existed before the creation. It is co-eternal with the mind of God. Geometry provided God with a model for the creation. So that kind of expresses this idea that geometry was not really an invention of humankind. It was really just a discovery or an understanding of the very primordial origins of creation. The geometry was the key set of parameters by which the world, the universe, by which creation itself was implemented from and externalized from the mind of God. That's kind of the idea right there. This is why many art and artists depicted God as a geometrician. So I think what I'll do is I'll share a screen here that I think really captures the basic idea behind sacred geometry. Oops. Come back here. There we go. There we go. This, of course, is the famous painting by William Blake, The Ancient of Days. Now, if you can see what he's doing there, that's the demiurgos, the demiurge, creating the universe. Now, what he's doing, and I'm going to stop share for a second and show you, is he's setting his compass upon the face of the deep. And it's that turning of the compass that imparts the angular momentum to the universe, that sets everything into motion, that then ultimately evolves, and after 14 to 15 billion years of this descending hierarchy of rotational systems, it has now culminated at this very moment, Chris, with you and I having this conversation. In other words, it took, 14.5 billion years for us to have this conversation. So appreciate the moment, Chris.
Definitely. Oh, yeah. 100%.
100%.
Yeah. And I know that, a big part of the construction of ancient megalithic structures was polygonal construction, and this also has to do with the sacred geometry, right?
Oh yes, clearly it does. I guess I'll do a few more share screens here.
Sure.
If that's okay with you.
Of course, yeah.
All righty.
We've got about 20 minutes left.
All right. right. Well, we'll do, let's see, I like this one too. This was the frontispiece to a medieval Bible. And this is sort of representing Jesus in his secret person, which was as a geometrician. And imagined within Gnostic traditions and some of the earlier Christian traditions as being the builder of worlds. And that was the capacity. And this is where Jesus's tekton comes from, which of course is translated as carpenter, but really means builder, a master builder. So this we see in the, particularly in the Middle Ages, during that particular fertile period of the Gothic, when all the great cathedrals were being built, and there was this, I would say, a sort of a download of cosmic esoteric knowledge that took place during that couple of centuries of the High Gothic, which ran from about the early 1100s to about the early 1300s. So go back to the idea of the compass. You'll notice in the compass that there is one fixed limb and one rotating limb. So that's the idea. That's sort of the same dynamic relationship that you find in the Tao Te Ching, the idea that there is stillness and there is motion. And through the combination of the static and the dynamic is where you get creation as we know it and as we are a part of. Any circle that you draw with a compass. Now, if you're looking at this image, the radius of the circle would be this, from the fixed point right here to the moving point, the moving limb. These are also called limbs of the compass, right? Or legs. So you've got the fixed one, you've got the moving one. Now, it just so happens that it's a geometric relationship that the radius of a circle, which would be the distance between the 2 points of the compass by which you're drawing the circle, it will step off around that circumference exactly 6 times, right? So if you take this point right over here and you start walking the compass around the circumference, it will return exactly to that point. If you're very careful. And you can demonstrate, you can prove mathematically or geometrically that that is in fact the case, right? So what you have here is, again, once you've created this circle, the next step, obvious step in creation of moving from the infinitude of a circle, from this undefined situation, this irrational situation, because there's no rational connection between the radius of a circle and its circumference. In other words, you can pick one or the other to represent as an integral value, but the other is going to be an irrational value. The two are irreconcilable, right? Except in a geometric level. Now, what happens is you're introducing into that irrational or immeasurable circle order. And nature does this too, because it utilizes this hexagonal geometry in some of the earliest stages of crystallization of matter, right? So you step around the circle 6 times, return to your starting point, and now you've introduced rationality into the system, right? And each one of these is going to be 1/6 of the degree of the measure of the circumference of the circle. So if you are looking for the most rational way of dividing and subdividing that circle, you want to pick numbers where you can get very small increments, so you've got a very flexible range of relations that you can incorporate, but you also want it to be rational to work with. And from that standpoint, 360 degrees was chosen because, for one thing, 360 degrees has a high number of factors. That means that by dividing a circle into 360 parts, you can get the maximum number of pie slices with nothing left over. Okay, so when we're looking at this particular picture, all of this is implicit in this, right? Because this is now the swirling primordial chaos right here. And now, Master Builder of Worlds is about to impart order upon this system by stepping the compass off around 6 times. What we have here now is a geometric principle that is represented and symbolized in a metaphor of the divine creation, 6 days, 7 days, and you think about 6 days of activity, right? There's your dynamic, followed by a single day of rest. And that's your fixed compass limb. This is the compass point that's at rest, and this is the one that's moving, creating the sixfold division of the circle, which is the first stage of the crystallization of reality out of the amorphous zone or realm that pre-existed it. So this whole idea is what's wrapped up in the idea of sacred geometry. And then so sacred geometry is just simply utilizing the principles of geometry to trace this creative process from the simplest act of placing the point on a piece of paper or whatever it might be. Now, on the building site, the geomancer, who was able to detect the patterns of energy in a landscape based upon the topography, based upon the mineralogy, based upon the hydrology, based upon its exposure to the plane of the ecliptic, and all of these other factors which influence the way energy moves through the landscape. Because bear in mind, the energy does move through the landscape, right? Just as it moves through the atmosphere, it moves through the solid lithosphere and hydrosphere of the earth as well. So the geomancer is the one who comes out there onto the building site and determines the pattern of energy that finds and locates that that natal point, the navel point, if you will, of the structure that's about to take shape, that's about to emerge from that site. The Greek term was losing me for a second, which it'll bop into my mind in a second. The omphalos. The Greek term was the omphalos, right? But many ancient cultures had a parallel tradition of finding the sacred center, and it was found by mapping the patterns of energy in the landscape. And once that sacred center was found, it was assumed that the pattern of energies in the landscape was fluctuating and variable, depending on all these external forces and internal forces, forces within the earth, movement of the tectonic plates, things that cause earthquakes, things that cause, if you have an enormous amount of rainfall, you have more rain being soaked into the ground, which makes it more conductive, because now it's going to be more conductive if the pores of the soil and rock have more moisture in them than if they're dry, right? Or the suns, the heating up or cooling down, the planets and the moon imposing tidal forces upon the crust, right? So now the idea is you've got this chaos of various forces. And when you take that initial pole, the idea is that pole, that first act of ritually inserting the gnomon pole into the omphalos, fixes the energies. It fixes the energies, right? And if you look and think about the word sacred, what does it mean? It means to fix. Just like the 5 fused bones at the base of your spine, which are fixed to one another, are the sacrum, right? So this is because you're using geometry. And that initial step of geometry is that the gnomon pole goes into the earth. It's like an acupuncture needle. And now what it does is it begins to systematically bring some order out of the chaos of these terrestrial forces, right? That's the first step. The second step is you now take your rope or your chain, your knotted rope with increments, or your chain that has links of a predetermined size. And just like with the rotation of the compass, you now extend out your chain and you make that first act of geometry, which is drawing the circle. And then it proceeds from there, you see.
Now, I'm sure if modern builders still use these techniques, we'd have earthquake-proof buildings. We'd have buildings that could work with the elements like the ancient, like they had in the ancient past, and these buildings could last thousands of years. But we don't see this anymore.
Well, we don't. But you asked about, I mean, there's so much we could dive into with sacred geometry.
Yeah.
Because I've just basically shown you the first act of sacred
Right.
geometry.
Yeah.
And then I jumped up and I showed you, I pulled this up for a second. Let's pull this up again. And I mentioned the angular momentum. And if you read a book on astrophysics or cosmology, one of the ongoing questions is, where is the initial angular momentum coming from? And here we're seeing the manifestation of that angular momentum. In other words, as the universe, the matter of the universe is forming, why is it creating all of these rotational systems? Why is it not just vibrating randomly instead of forming coherent rotational systems? Because we look, everything has got angular momentum. The Earth's rotation on its axis, the Earth's revolution about the sun, the planet's revolutions about the sun, the moon, the sun itself is manifesting that angular momentum. Well, in the ancient cosmological models, it was this cosmic act. It was God placing the compass upon the face of the deep and turning the turn of the compass. Let's see if I've got the biblical quote here. Yes, from Proverbs chapter 18. It says, I was set up from everlasting, from the beginning, or ever the earth was, while as yet he had not made the earth, nor the fields, nor the highest part of the dust of the world. When he prepared the heavens, I was there. When he set his compass upon the face of the deep. So that's referencing this process right here. In 1960, an early book that I read on this decades ago, Paul Jacques Driot, who was a fairly well-known architect, French architect in the first half of the 20th century. In his book on architecture, he's referring back to ancient civilizations and the idea that an architect in designing utilizes numbers and proportions, relationships amongst things that can be expressed through mathematics, through numbers, through proportions. He said, quote, the world around us is a world of numbers, numbers that spell life and harmony. They are organized by the geometry of figures, all related to one another according to a sublime order into dynamic symmetry. Glimpses into this magnificent kingdom form the basis of all our knowledge. And it seems that in this domain, the ancient civilizations had gone further than modern science. Very interesting outlook to have in 1960.
Yeah, definitely.
But I think we could safely say that in some respects, anyway, the ancient peoples had access to some domain of knowledge which has been forgotten. And then that kind of brings up an idea you broached upon at the very beginning of this conversation, the idea that the cataclysms have a tendency to cause things to get lost and destroyed. So the key is figuring out how to preserve. Now, that's a big part of what I'm trying to do, is because I feel like by establishing with a degree of accuracy the pattern of the past, only then are we going to be able to project what could potentially await us in the future. And listen, when we look at the past, we've got huge volcanic eruptions, we've got solar storms, we have ice ages, we have impacts of asteroids and comets, and we start looking at all of these possible things which have caused major interruptions and destructions of civilization throughout the millennia. And right now, it seems like a lot of that is being de-emphasized. Why? Because there's a politically driven model that's being pushed out into public consciousness, which is we are to blame for it all, basically.
Right, yeah.
And that it is now being used what was called global warming, which had a very specific meaning within the range of the physical phenomena of weather and climate change, has been changed to the term climate change, which can basically now mean anything, including, global cooling. Global warming can now cause cold weather. But if you go back to the original models, how you get global warming to cause colder weather is a very iffy assumption. And this idea of the polar vortex and some of these, we don't have time to talk about that now, but that is a very tenuous conclusion to draw, that that somehow it's the global warming. And if you got me back on here, we could talk about all kinds of things.
Oh, yes.
Talking about periods when the Arctic Ocean appears to have been completely free of ice, periods in the not too distant past when sea levels might have been 4 or 5 or 6 feet higher than now. Talking much more about the role of the sun, the geomagnetic fields, how ancient cultures may have employed some of this knowledge. Because what you did by asking that last question was you opened on a door onto this whole other possibility, and the idea of what did these ancient peoples know.
Yes.
And I think it's at this point unquestioning that they knew things that we have forgotten.
I would definitely have to agree, and I'd love to have you back on to discuss all of that. We've barely scratched the surface of this stuff again, and there's so much more we could talk about. And I love our discussions, so we'll have you back on sometime soon.
Thanks. I'd like to say that, I do a regular podcast as well.
Yeah.
We've got about 62 episodes. And Chris, if you get a chance, jump over to the new platform that's rolled out called HowTube.
HowTube. I will. Check that out.
HowTube, yeah. Or, go to randallcarlson.com. I'm partnering with them. And randallcarlson.com will get you to HowTube. Check it out. They're looking for some content creators to feature.
Oh, great.
And I think it would be possibly a good fit. And there might be a lot of potential benefits by allying with HowTube at this early stage.
Yeah, at this point, we're definitely looking for all kinds of new platforms to be on, especially with the growing censorship. So I will definitely check that out. Yeah.
Yeah, check it out. And, we'll talk again. I'm going to just mention briefly, I am no longer associated with the website Sacred Geometry International for multiple reasons. But the sales of just want people to know that a lot of my work and content is being still sold there, and I am not receiving any remuneration for it. So anything that's there is soon going to be available on my new website. So just know that if you're purchasing anything, a class or DVD or anything from that website, I receive no remuneration from them. So,
all right.
So,
very good to know.
And, spread the word so people
Definitely.
know. Yeah, thanks, man. So, Chris, just hit me up. I'm going to be doing a seminar, actually my first introduction to sacred geometry, hands-on week-long seminar in Sedona next month
nice.
in April.
Very nice.
If you go to HowTube or you go to randallcarlson.com, there will be the specifics there for that. It ought to be.
I'd love to make it out to Sedona. We've been planning hopefully planning a trip there soon, so we may even be able to make it out there.
Well, that would be awesome, man.
Yeah. Thanks again, Randall, so much for coming on, and we'll definitely have you back on soon.
Thanks, Chris. Talk to you soon. Looking forward to meeting you in person someday.
Yeah, hopefully so. And until next time.
Happen.
Yep.
Yeah, man.
Yep. Until next time, everyone else, have an excellent evening.